Hello guys, in the previous video we managed to get the day 11 part 1 done, and in this video let's continue the part 2. So let's jump to the business directly. So in the part 1 we need to calculate basically 25 iterations of splitting these stones up, and in this part 2, oh this is small, so basically the historians sure are taking long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking a total of 75 times? Okay, let's start by just adding the day 11 part 2. So 75 times. So basically it's exactly the same as the part 1, only difference is that the need to run these. Let's see, yes, now it should run. Good. Only difference is the amount of iterations we have. This somehow feels a bit too simple, but let's try. Let's just test that we can still get the number. So we got 233,875. Yes, so this works. So let's just jump the range from 25 to 75. Okay, slows down. I think this is kind of the crucial part here. That let's see, it's now 22 seconds, around 32. Okay, I think we need to somehow make this a bit more performant. Yeah, it's almost slowing down. And actually I can see also the system RAM usage also to grow. So I think we are kind of heading to the same bottleneck that we had in the earlier days challenge as well. Yeah, it actually increased quite rapidly. Okay, so if we think about the problem, so what we have stones, which are basically numbers, and each number is kind of its own, so two different stones are not related by any way. Only kind of way that stones are kind of related or can be related is that if they're split up. Okay, yeah, this is 36. Let's run, or let's run this meanwhile, thinking a bit. So okay, I think I'll just copy these to own cells, maybe, so we can modify these a bit. So since these are numbers, and basically if we have a list of stones, we may have also duplicates there. Yeah, our system will crash soon, I think. So we may have duplicate stones there. So in that case, using the stone list and the data structure, might be a bit overkill, or not overkill, but like it might just add the complexity. So what I'm thinking that since each iteration, if there is, let's say, or in one iteration, if there is, let's say, 30 stones with some number, let's say 0, we know that for each stone we need to apply the same rule. So we don't need to check for every zone with 0 value or number that what we should do, but we could kind of do this. So could we use dictionary for this? I think we could try. So what we would have there, we would have maybe stone as a key, because now we do so that we have this initial list of stones and then we have this temp store list, which we kind of collect the new stones per each iteration. So if we would replace this just to be a dictionary, the new stone list, so this could be just a dictionary as well, although for this, so we would like to populate it so that we have stone number and count of stones. So actually we could use dictionary, but I think counter might be a bit better. From collection import counter, yes. And to populate this, I think, can we do it like this? So just use the raw input that we have here. And let's actually check what kind of stone counter we will have. Oops. Like this. Of course. Need to import it. And well, maybe I could just do like this. Okay. So this represents here. This represents quite well our input. Okay, so that can be like that. And then temp stone list. I think we should create this actually here. Temp stone counter. Let's do the counting here as well. Temp stone list. Yeah, let's remove. And here we want to loop over this, because we want to, in the end, we want to replace. So the kind of same setup kind of as we had. And here I think we need to loop the values, and from there we get first we get the stone number and then the stone count. Yes. And then here we can apply rules. For this we will give the stone number, and then we need to refactor this. to be int, yes. Then if stone that like that, then we can just return 1 stone, yes, stone midpoint, stone, I think stone second parties are just without the stone data structure, and here as well. Yes. So we have the same rules now, but we just use integers, so just the stone number. And then we get the stones, new stones. We don't have this temp stone list, so we need to update the temp stone counter for temp was new stone in new stones, so we need to loop these through, and yeah, this was just adding them to the list, but we need to update the dictionary, so the temp stone counter, so new stone is the number in the stone. So if there was a split, then, or like anything, we will just set the stone count, then be the value. I think. So now we have that we initiate the stone counter. Yes, it looks like this. Then we initiate this temp stone counter. Yes. Then we have the loop where we loop the stones in new stone counter. Yes. From there we get the stone number, which is this, stone count, which is this, that. Then we apply the rules here. We get list of new stone numbers. Maybe this could be like this, so it's gonna more clear. And then we update the temporary counters new stone number value, and actually it's plus equals stone count, because if there is already stones with that number. And let's actually try that. Can we get the same result with this as we did for the part 1? We run that already. We don't need to run anything else. Okay, cannot unpack non-iterable int object. Aha, values I think is returning only the right side. Let's double check. It might be that I need to use. Yes, is it items? Okay, yes, items is returning the double. Okay. Aha, yes. So for this, so we need to calculate how many stones we had. So print sum, and for this I think we can use the values. Okay, it matches, and actually it was quite fast, but it was fast earlier as well. Let's then try the 75. Yes, okay. This at least run. Okay, this is a big number. I'm not any more surprised that the list solution was taking so long and RAM usage was increasing. So let's try this one. Okay, good. That was the correct answer. So now we have managed to get the day 11 done. This was quite tricky. Interesting, but tricky. I liked the challenge in this one. I think that's all for this time. I think it's good time to end the video here so it won't get too long. If you liked the video, drop a like, subscribe the channel, and see you guys in the next video. See ya!